In this geometry problem, we're given a square ABCD, and P point is inside the square such that the angle here, PDC and PCD, are equal and both equal to 15 degrees. We want to prove the triangle ABP is a regular triangle. Alright, this is a geometry problem. However, today we're going to try to solve it using trigonometry and algebra. That is, we're going to use analytical geometry to solve this problem. And of course, you should think about a pure geometric proof. We need to place a coordinate onto the geometry diagram here. So what do we do here? We choose point D of the square to be the origin. For the convenience of calculation, we're going to choose the side length to be 2 instead of 1. Alright, so with this coordinate, we can do some calculations. And we have this vertical line here, EF. We know that the F as a position here is 1, 0. Right? So we need to find different quantity here is what is the height of PF. We're going to call it H1. And what is the height of PE, which is H2. In order to show that triangle ABP is a regular triangle, so we need to show the H2, the magnitude is going to be square root of 3 times the magnitude of AE, which is 1 here, right? Which is square root of 3. All right. So we know that the whole EF equal 2. So which means we need to find H1, which is 2 minus square root of 3. Okay. How do we find that? So of course we know that H1 over DF is 1, right? Is H1 over 1. That's going to be tangent of 15 degrees. How do we find tangent of 15 degrees? So let tangent 15 degrees be T, and we know the formula here, right? Here, the theta be the 15 degree. The trig identity here we're going to introduce, which is sine 2 theta. The formula that we have is sine 2 theta equal 2 tangent theta 1 plus tangent theta square. All right, so that's the trig identity that we're going to use. Right here, of course, tangent theta is equal to T here. Right, so we plug in, which is sine 30 degree, which is 1/2, is going to equal 2t 1 plus t squared. So you're going to have quadratic equation from here, right? So which is t squared plus 1 equal 40, or t squared minus 40 plus 1 equal to 0. And we know that this quadratic equation, the roots here, which is tangent 15 degree, right? 15 degree, which is a value of h1, h1, right? The length of this height. So we're going to equal to, we're going to plug in, which is 2. This is 4 plus and minus square root of b squared minus 4at. So b squared is going to be 16 minus 4at. So that's going to be 4 plus minus 12, which is 2 square root of 3 divided by 2. That's going to equal to 2 plus or minus square root of 3. Now here, for tangent 15 degree, we know that is smaller than 1. We're going to take the value here. So h1 equal 2 minus square root of 3. So we proved the results. So here, earlier we said that we need to show h1 equal to this, right? h1, which is this part here, right? So this value here is 2 minus square root of 3. So h2, of course, the magnitude is going to be square root of 3. And by the symmetrical property, we know that this is isosceles triangle here, and the height equals square root of 3. So we conclude that the triangle ABP is regular. Now, that's an analytical geometry method. We use algebra and trigonometry. Now, how do we prove this using pure geometry method? That's for the next video. Alright, hope you enjoyed the video. Thank you for your time, and please like, share, and subscribe to the channel.